I'm Katie, this is Brian. We're really excited to be here teaming up across our teams, across our companies to talk about applying your cyber threat intel to attack. If you've heard an attack briefing from one of us or other people before, this isn't that briefing. We're really focusing here on the data sources that we've mapped to attack and the limitations and biases of that. So I think it's really appropriate that we came right after Charity talking about biases. So let's dive right in. Who am I? I'm Katie. I'm the Attack Threat Intelligence Lead at MITRE, which is a nonprofit, works in the public interest, doing government work as well as research and development projects like ATT&CK. I'm on the core team that maintains ATT&CK, and I focus on kind of spreading the word on how ATT&CK is useful, especially for tracking your adversaries.
And I'm Brian from Red Canary. We were one of the first users of ATT&CK throughout all the detections we perform, and really found it as a great common language across all of our customers, all of our partners, and Katie and her team for giving us a good way to talk about this type of intelligence without having that question and challenge we talked about earlier, which was different teams using different names for different techniques or actors.
Yep, absolutely. And he also wears really awesome red pants, so that's cool. What we're going to talk about today, I mentioned a little bit different approach. We're going to start briefly mentioning what ATT&CK is, in case you haven't heard of it, get on the same page, how it's useful for cyber threat intel. Then we're going to give a tale of two approaches, right? For my approach, we've mapped hundreds of open source threat reports to ATT&CK over about 4 or 5 years. Brian's team has mapped their detections at Red Canary to ATT&CK. And we're going to talk about the biases and limitations of each of those approaches and what we've learned from that data. What kind of takeaways do we have for you all about how you can apply ATT&CK-based data to network defense? So what is ATT&CK? Never heard of it. Simply stated, it's a knowledge base and a framework of adversary behavior. So what are the things adversaries are doing? We break it into this matrix view, which is the way a lot of people look at it. Across the top, we have what we call tactics, which are the adversary's technical goal. Things like how do they gain initial access? How do they move laterally? How do they persist in an environment? Under that, we have what we call techniques. You can probably see where this is going. Techniques are the implementation of that tactic, right? How that technique or how that goal was achieved. So for persistence, that's a tactic. And then a technique example would be scheduled task. Next up, procedures. That's how that technique was implemented or instantiated. So this group used XYZ scheduled task would be the procedure level. So ATT&CK is maintained by the team at MITRE, but we rely on community contributions. Red Canary has done a ton. Many of you in this room have probably contributed and given us feedback, but we're the maintainers. So why it's useful for cyber threat intel? You know, Brian mentioned that common language. I think whenever we structure our cyber threat intel, there's a lot of benefit from that. And I talked about this a little bit at CTI 101 last night, why we use frameworks like ATT&CK, like Diamond Model, Kill Chain. It allows us to compare groups to each other and groups to defenses. Rob Emily really hates actionable intel. And I get the point. All intel should be actionable, but I think so often it's tough for us as intel analysts to give our defenders the intel that they need to write detections. And I think ATT&CK has a lot of power there to help make intel more actionable to defenders in a really direct way. Also, I don't think it's been said yet this morning, moves from IOCs, those indicators like hash values, IPs, up that pyramid of pain, take a shot, to TTPs, to behaviors that are tougher for adversaries to change. So that's some of how I think ATT&CK is really useful for CTI. So we're going to talk about two different data sets. The MITRE data set, it's not really our data. It's all of your data. All of the amazing blog posts, reports, threat research you've been doing for the past 5 years. We've been mapping open source public reports like blog posts to ATT&CK. We're up to about, I had my colleague Adam count this week, about 400 of those. Really important limitation of this is we rely on the reports that everyone gives us, right? And it depends on what you all put out there. We also try to focus on APT groups, more advanced adversaries. I'm not going to map every single commodity malware out there to ATT&CK because it's time consuming. We have limited time to do this, right? But from these 400 reports, we have a pretty rich data set that if we realize those limitations, we can start to play with. I wanted to walk through how we map through map to ATT&CK in this human way. So this is a great report on APT 15 from NCC Group. Is anyone here from NCC Group? come talk to me because I've never met those folks, but they do great stuff. Basically, we walk through and we think about the behavior behind this. It's a different mindset than looking for like an IP address, right? You think of the behavior. So I've highlighted the different techniques, and we'll walk through. First one, creating batch scripts. Scripting is a technique we'll talk about a little bit in our top technique analysis that we do. Registry run keys, really common persistence method that adversaries do. Walking along Windows commands, many adversaries use command line, right? That's an execution technique that we look for. Whole host of these, task list, ping, netstat, system info, ipconfig. These are different discovery commands that adversaries will often do. They jump on a box, they want to know, where am I, what other devices can I move to? Credential dumping, really common technique, as we'll see later. Pass the ticket, Kerberos golden tickets, that's how we define that. Key logging we defined as input capture. And then lastly, email collection from Microsoft Exchange mailboxes. So in this one report, we have this handful of techniques, and it's all getting towards that behavior. From there, we'll talk about how we've looked at top techniques and then how we can apply that to defenses. So I said we're going to talk about biases, and I really believe that talking about biases and limitations doesn't make you look weak as an analyst, it makes you look strong. It takes strength to admit what your limitations are. So this process we've done, it's really thorough and nuanced, right? I can go through, I can think about, well, what is ipconfig? Does that fall under this technique? What were they really doing here? And so you can find techniques through human analysis that you might not be able to find through a machine learning type approach, or NLP, which some people are doing research in. The drawbacks, this is really slow. I'd estimate that a meaty blog post could take me an hour or two. Some of the 50, 60-page reports might take me a week, like Operation Blockbuster. That one was like a 2-week process. It was a meaty report. So it's slow, and it can be really tough to learn because there are over 200 attack techniques in enterprise attack right now. Also, we talked about biases. It's subject to human biases, right? If I have seen the previous technique a lot in reporting, I'm more likely to see that again. You can try to hedge against that by working as a team, but there's still going to be those biases there that you need to be aware of. And of course, we rely on the community to publish these reports. We know a lot of people are hesitant to share information about post-exploit behavior. So we hope that that'll continue. I think the community's opening up more and more. We rely on that to make our mapping work.
So when Katie and I got together and talked about combining our two data sets, I think we both came into this thinking, hey, MITRE has a ton of data from creating attack and mapping intelligence to it. Red Canary's remapped a bunch of our data over the past 5 years. We're going to have a lot of overlap in this data. We're going to come to a lot of similar conclusions and hopefully answer this question for you that we all get a lot, which is, where do I start? The attack matrix is huge. If I could be really good at one of them, what would I do? What's been fascinating is as we get deeper into the actual results, we found out that there's a lot of differences between the data. And that led us to really rewrite our conclusions and dive deeper about 4 or 5 times, because every time we peeled back a layer of the onion, we learned something that was different about our approach that led to these different results. And I think one of the things we learned was who you are and what your mission is going to actually influence where you should start with the attack matrix. So a little background on Red Canary's process. We're looking at data that comes from about 5 years of security operations monitoring. One of the questions you may have is, hey, if attack has just gained big prominence in the last 2 or 3 years, how does Red Canary have 5 years of data? Well, one of the benefits we'll talk about is that because all of our mapping is done inside a structured system and structured data stores, when we mapped our detection rules and techniques over to attack, that meant that we could look back in time and all of that past data was mapped as well. The other unique thing we have from our data sets is that as of about a year ago, we became the tech stack behind a large number of incident response engagements. And so we're now seeing 2 parts of this world. We're seeing both the day-to-day security operations monitoring, but then we're also seeing a lot of post-compromise, post-incident engagements as well. And so to give you an idea of our process, we'll walk through kind of what that looks like. So this is what we call a Red Canary detector. Sits in structured data, and the 3 highlighted parts there are the most important bits. So first of all, what's the name of this detector? What are we looking for? In this case, we're looking for, on Windows, an auto run key making a registry modification by command. One of the things you'll note about our detectors is that we've learned a lot of lessons that it's very important to write very, very specific rules, because then you can better understand the probability of that turning into something evil and how evil it's going to be. So this is not just something where we say we want to find anyone who modifies an auto-runs key. We actually want to know when does command operate or modify that auto-runs key. That will be different than if something like PowerShell modifies an auto-runs key. Some of these are more common with system tools, some of them are less common. It's important to tell the difference. How we match them, you can see we have this bit of code up at the top right that says, do we have any registry modification value that is one of the known auto-runs keys, and does it come from a process who is likely command? That means it could be the same MD5 or SHA of command. It could be called command.exe. There's a bunch of different ways we try and figure out what is that process. And then finally, at the bottom right, you can see we've mapped that to attack technique T1060. So go ahead and we'll talk about some of the biases of that. So here's the pros and the cons of the way we do it. One, by having a system map this, we have the ability to do this on huge quantities of data. We're looking at something like 250 to 300 terabytes of endpoint collected data every day. That all flows through this system. The great thing is it's highly consistent. If we identify a certain chain of behavior and say that this is this technique, it's going to be mapped and identified that way every single time. Compared to manually sifting through reports, we have the advantage of letting the machines do it for us, so it's very fast. And we end up with this benefit that I'd really recommend all of you aim for, which is structure your data as much as possible. You know, I think one of the things I've learned and would implore all of you is that as you produce these threat intelligence reports, structure that data in some way. Even if you don't have an industry standard to follow or have ways of talking about it, at least at the end of your report, write it up in YAML or JSON or something, so that later someone else can go through and review that data without having to guess through words and try and say, hey, you said it's probably a command line technique. Does that mean it is or it isn't? So structured matters a lot. There's a bunch of downsides though. One, we're only going to map known techniques. As opposed to Katie's team, if she's reading through a report and says, wow, that's really interesting, they used a new technique I've never seen before, I need to go make a new technique and propose that to the attack team. For us, we're not going to see that on the first pass we take through the data. The other side is that we have no ability to apply nuance or interpretation as the data is coming through and being mapped. One of the places where that's most painful from an analysis perspective is that there are attack techniques who map to multiple tactics. And so in those cases, when we identify those, the platform generally doesn't know how to say, hey, I saw technique T1060, is that being used for persistence or is it being used for defense evasion? In most cases, the platform doesn't go. There's not really nuance to teach the system of that yet. And then finally, and you'll see a lot of this as we dive into the results, we're only mapping to what we'd call detection-worthy events. A great example of this is the attack technique about deleting files. If you try and write a detection rule for deleting files, it will work great. And your CERT team will hate you and they will turn it off immediately. So Red Canary's data is really focused on find that initial big bang so that we can quickly get that out the door and respond to it, as opposed to being extremely thorough, like Katie said you find on the human analysis side of things.
So we told you about our two data sets. Which one should we use? Why not both, right? You know, we talked about the limitations of each, and if we combine those data sets, those limitations aren't going to go away, but it does tell us that where the commonalities are, we've seen in two different approaches that have their own limitations, their own intents and goals. If there's commonalities, I think those are worth looking at. Yeah, you've talked about limitations. It'd be great if we could actually see some data. We got you. It's coming. So we get this question all the time. What are the top techniques? We talked about limitations, so here they are. Based on the groups and software that we've mapped, based solely on the publicly available reporting that we've done that's focused on APT groups, these are the top 20 techniques. A couple interesting things as Brian and I were chatting about what the differences are. You'll see a lot of discovery techniques here. You know, things like from that report running like ipconfig, system info. And again, talking about those biases, well, IP-config, I know that's an attack technique, so when I see that, I'm going to map it. But one of the interesting things that we noted in the difference in our approach, the discovery techniques aren't quite as common in the Red Canary top 20. They are in attack because the reports we use tend to go through the entire intrusion, right? So you're going to go back and look at the discovery, how they get in. The number one, standard application layer protocol technique, that's a command and control technique. So that's sort of standard things like HTTP, DNS for C2, really common. So it doesn't surprise me that's number one. Other execution techniques that made the top 20, PowerShell and command line, we know those are super common. One interesting thing in looking at this top 20 is also not just what's here, but what's missing. So one that jumped out at me, so our initial access tactic, spear phishing. Where the heck is spear phishing in the top 20? Well, that goes with knowing your data set and where it comes from. We added the spear phishing, that initial access tactic, we added that like a year or so ago. So the other techniques existed in attack for much longer than spear phishing did. So of course we're going to have more data there. So interesting to look at not just what's there, but what's not there.
So on the Red Canary side, there's spear phishing attachment, shows up as number 5. What you'll see in terms of kind of philosophy change between the MITRE data and the Red Canary data is whereas the MITRE data is very heavy on the discovery side, now on the Red Canary side, you see it's very, very heavy on execution. And not just execution as the MITRE-defined tactic, but overall things that are running on systems, things you'd expect from applications, right? You have entire programming languages like PowerShell who shows up at the top, no surprise. Scripting, exact same thing. It's like PowerShell on steroids. All of this stuff is happening on systems that leads to that data being very prevalent in our data set. And if you dive forward, one of the things we thought would be interesting is let's look at those top 20 techniques from both MITRE and Red Canary, and let's map them by tactic. And we're delving into, maybe unapproved by MITRE territory here because
I'll allow it, it's okay.
They've done a very good job of saying the attack tactics are not meant to be in order. They're not meant to be a kill chain because we all know that as we look at real world attacks, adversaries don't always go in some linear progression. What we did though, because we had this theory about like, why is this data so different between MITRE and Red Canary? We looked at the attack tactics and said, well, hey, based on seeing hundreds and thousands of these, what order would we put them in? Like if you had to pick an order, what would they be? And so this is the order we laid out, call it the attack chain or something like that, and roughly just shows how do adversaries get into systems, take action, and then at the very end, exfiltrate data out. And it kind of proves this theory that we had and it starts to make a lot of sense. Red Canary's detection sits very, very far on the left side of things. Most of the techniques we find are not really left of boom, they are at boom. The attacker has gotten on a system, they are trying to evade defenses, they're trying to execute. If Red Canary, if the data we identify has a lot of things that are far to the right, when we start talking about persistence, discovery, lateral movement, if we spend a lot of time there, that means it's a really bad day for all the enterprises we're working with. But it makes a lot of sense if you think about the MITRE data. They're looking at actual breach reports, they're looking at incidents that have already happened. Really for it to be worthy of ending up in an intel report, it's gotta go all the way to the right side of things. So interesting takeaway from the data we found. Going a little bit deeper into Red Canary's data set and what we found, now if we look at all of the techniques overall by tactic, here's where you can really see some of the strong tactics show up. Huge amounts of defense evasion and execution. These two colors you see, anything that's marked in red is what we call malicious software. So something that we've confirmed is actually malicious software, could be commodity, could be custom, anything across the board. Suspicious activity is in yellow. That's most commonly where you see system tools that come on your boxes, adversaries living off the land, being used for evil purposes. So if we dive into some of those, wanted to show and kind of give you an idea, where should you start? If you could pick attack tactics or techniques to be exceptionally good at, where do you start? Start here. Start with the programming languages sitting up at the top, right? Scripting is huge. People use scripting to evade defenses all the time. Reg Server 32 is interesting, right? As opposed to something like scripting languages or PowerShell, which is wildly broad, how in the world does Reg Server 32 end up at the top of the list? We actually have a bunch of theories. One of it could be that the king of Reg Server 32, Casey Smith or Subt, sits at Red Canary and comes up with this evil all day long. And so maybe we have this really strong immune reaction to the fact that he's doing terrible things with that all the time. It also could be that the teams we work with like to throw unique new techniques at Red Canary in order to make sure we're doing our job. So maybe that feeds back around and thus we get tested with a lot of it. But I will say from looking through the data as well, Reg Server 32 is very commonly used by both APT adversaries as well as day-to-day commodity applications. And so it does seem like that is a really good technique to get good at. Same thing with masquerading we saw on the MITRE data. If we go look at the execution side, it's a no-brainer. It's PowerShell. It is PowerShell. It's always going to be PowerShell. Until you have PowerShell v5 everywhere and have deleted all other versions off your system, that chart probably looks the same for the next 5 years.
So we really want all of the talks at the summit to be actionable, right? So we wanted to give you some ideas for how you can put this into action, how we've actioned it, and at the end, I'll suggest how you could take this away and implement it for your teams. We've got to have a matrix view with the navigator. This is money. So Red Canary top 20, again, you can see the execution, the defense evasion, a lot there. So we take those top 20, and then the MITRE top 20, and then for any of my attack presentations, we've got to overlay them. So we took each top 20 and found there are 7 overlapping techniques. And even there are limitations of the data that we've talked about. But if based on these 2 approaches, these 7 techniques popped up in both of those, I think this is a pretty darn good place to start with our defenses. So what were those overlaps? PowerShell, not a huge shock here. That was Red Canary number 1. We've also thrown up the counts for each of these for you to get a sense of what our data sets look like, what our volumes are. Red Canary is in thousands, hundreds. MITRE, we had about 400 reports we've mapped. So there are differences there in those numbers, right? And based on our approaches that we previously talked about. Scripting, really common. Command line interface, these execution techniques that Brian talked about are so important. I mentioned in the report earlier, registry run keys. If you're not looking at that registry data, this is a really low-hanging fruit kind of thing that so many adversaries are doing across both our data sets. Masquerading is a really interesting technique. That would be something like an adversary naming a registry run key Adobe Updater, right? They're kind of trying to trick the analyst into thinking it's something it's not. One thing I always say with masquerading is a lot of it's about education of your analysts. We talk about our biases. I'm automatically going to think Adobe Updater is benign. That's good. So educating your analysts that adversaries are doing this can be very powerful.
So what's that mean for you from a defense perspective? So what we wanted to walk through here was each of those 7 overlapping techniques and the notes you can take right now and take back to your teams to make your defenses better based on it. So if we start with the big one, if we start with PowerShell, the single best thing you can do is get v5 out there, turn on enforcement, turn on script block logging, and then ban all other versions of PowerShell off of your systems. That second bit is very important. If you leave old versions of PowerShell on it, the adversary will just use those, or he will show up and bring his own version of those. You don't want that. Now, go back to the very initial talk and what Whitney talked about with logs. Welcome to GDPR hell. Your PowerShell logs may have who knows what inside of them. They're going to have plain text passwords from your IT organization. They're going to have IP addresses. They're going to have usernames. This is one where, from our perspective, it's well worth the compliance risks. These are logs you have to have. A big part of this as well with PowerShell is I think every security team needs to have a key strength of knowing your command lines. From all the data we've seen, if we look at all the detectors we have across time, if you could pick one piece of data and be exceptionally good with it, it is command lines. There are lots of ways to get around them, don't get me wrong. And the problem is, most security teams are not good at them. And so if you're not good at them, attackers just walk in every single day and they use easy stuff that if you just looked at all your command lines, you'd identify. So we should all make it much harder for them and force them to get more clever by being really good at looking at your command lines. On the scripting side, ends up being very similar. One of the things you'll see unique about phishing is that parent-child relationships are key to identifying these phishing attachments. Look at everything that comes from your Outlook programs, from your web browsers. If they spawn children that look in any way fishy, then you need to be flagging and going deeper on those. On command line interfaces, exact same thing we talked about. It's kind of this hybrid of both PowerShell and scripting. Know 100% of your command lines, and then understand those common parent-child relationships. This is something where I think, as a summit talking about cyber threat intelligence, this is the type of community intelligence we could all share that would make a huge difference for our teams. If you have the question right now, hey, I saw Chrome spawn, pick something, pick NetSPN. If I saw Chrome spawn that, is that normal or is that not normal? Right? Who do we go to get those questions? Who has the database that says, oh, well, it turns out over time, this normally spawns that? Right? This is something we talk to Microsoft a lot about. They have a ton of applications that come with their operating systems, with their developer tools, that can do all sorts of really cool things, but in most organizations don't ever run. Right? We need to know that so we as defenders can say, hey, you just ran the Microsoft build processor that can turn XML into code. Well, that's really weird. We don't want to see that happening, right? So that's a good type of intelligence we can share. On the other tactics, know your systems. Know your run keys, know what happens when systems start up. The more consistency you can get from that on an IT side, the better. This is one of those common cases of better security through better IT. Masquerading is interesting because Katie talked about it being from an auto-runs key perspective. From what we see on the Red Canary data, most of the masquerading we see happens around binaries. And so one of the best things you can do there is understanding what are the hash values that I should expect from common system binaries. This is entertaining to me because it's kind of like cybersecurity time warp for me. It's like the NSRL. Right? If we had the NSRL for every single Windows binary across time and all of our security products could quickly look that up and say, hey, that's a weird version of command.exe. It looks signed by Microsoft, right? Because it's easy to fake this signing data on Windows. You can see Graeber's talk about it and how to do that. But how do we identify when it's not really command.exe, right? That's huge intelligence that we all need. On the obfuscated side, again, the PowerShell v5 logging makes it very easy to see what PowerShell is actually doing, even if the command lines coming in are encoded, and that's key to figuring out what's happening there. And then credential dumping is frankly probably the hardest to identify on this because you have to dive deep into every single process that runs, what modules they're loading, what other system tools they call. So get really good at the other 6 before you dive into 7.
Good advice, and we really wanted to take a moment to talk about that because, again, attack can help you look at what adversaries are doing, right? Top 20 from 2 data sets, what are the adversaries doing? The common 7, and then there are some ideas you can go back and you can tell your defenders, here are things that Brian has suggested from his Red Canary detection knowledge to be looking at for your defenses. So we've given you those 7. Maybe it's a starting place. Don't stop there. Add your own data. Last night at CTI 101, we had people raise hands who's using attack. There's a lot of you. So if you're mapping to attack, take our data, add yours in. Know your limitations and biases of that data, but add it in. And from there are other talks about how you can map your own environment, assess your environment and your detections, and look at that gap area, right? That's where the adversaries are going to lie in what they're doing that you're not detecting, and improve your defenses based on threat intel. That's the whole goal. So takeaways, know your limitations. So important as you use attack. We think it's a powerful tool, but you need to know the biases that you bring to that. Combine your approaches and data, right? We've combined 2, add yours in. And on that note, on sharing data, I just wanted to tease, MITRE's looking right now at how we could create a possible sightings ecosystem. How could we as MITRE bring together all of your data about attack technique sightings, anonymize that, and share it back out? So if that's something that interests you, please come chat with me at the summit. I'll be here today and tomorrow, because we think there's power in sharing this data about what adversaries are doing with the goal of using attack to apply intelligence to your defenses. With that, I think we have 5 minutes for questions.
We're going to, just to lunch, we're going to skip questions for now.
You're killing me, Rick.
But you just promoted being available for questions.
I'm absolutely happy to chat.
Yeah, so great job, great data, guys. Really appreciate it. Thank you very much.
Thanks, Rick.